All right, the next ones, we're going to do confidence intervals and prediction intervals from simple linear regression. Again, we're going to have some formulas that we need to know. And so in order to do the prediction interval, my equation there is that I'm going to take y hat, which is my value here when I use my equation that's given in my problem, plus or minus t, we're using the t1 sub alpha divided by 2, and that's just found the same way we did before. We'll talk about that in a minute, times the s value times the square root of 1 plus, and then we have to have the given, or the value here. I'm going to put a whole bunch of x's, but those are asterisks. There, we'll put asterisks. The given value, which is going to be given right over here. So this number, they're going to do the calculation for you. And so when I put 1 plus the given value is that one that we have right here. All right, so it says, movie studios wishes to determine the relationship between the revenue from the rental of comedies on a DVD and the videotape and the revenue generated from the theatrical release of such movies. The studio has bivariate data from a sample of 12 comedies released over the past 5 years. These data give the revenue X from the theatrical release in millions of dollars and the revenue Y from the DVD and videotape rentals in millions of dollars for each of the 12 movies. The least squares regression equation computed is, and they give us that equation. The studio has plans for the DVD release of a comedy that grossed about $32.6 million in theaters. The studio has predicted the rental revenue from this release using the regression equation and is now interested in both a prediction interval for this rental revenue and a confidence interval for the mean rental revenues of the movie generating the same theater revenue. The studio has already computed the following for their data. The mean square error, which is this value here, and then this crazy value here they computed for you that is going to go over in the formula. Based on this information, assuming the regression assumption holds, answer the questions in the table below. First of all, it tells us that we want to do a 90% prediction interval. That is important because we have to do this right here. So 90% prediction interval again means that 90% is in the middle and we're finding the percent on each end of my expression here. So we do 1 minus 90%. 1 minus 90% would be 10%. We then divide it by 2, so 5% would be on each end. So we know that we're going to do t sub 0.05. Now we know that on our t value, we also have to do the degree of freedom. The degree of freedom on these problems are going to be n minus 2. N, how many comedies in this case? How many movies did we do? We did 12. So 12 minus 2 means we're going to have 10 degrees of freedom. So when we put that in here for the t sub, we're going to have t sub 0.05 with a degree of freedom of 10 is what we want to use. So we got to do our prediction interval for a 90% confidence interval. Value for the rental revenue in millions of dollars when the theater revenue is $32.6 million. So first thing we're going to do is figure out what the y hat value is for 32.6. So we're going to use this equation here and say, okay, y hat is equal to 3.50 plus 0.16 times the 32.6. And we're just going to grab our calculator and figure that out. So again, I'll grab the calculator, put that in there. Hopefully you're doing the same thing. And I'm coming up with a y hat value of 8.716, or 8.7, yep. 8.716. That value here is my y hat value. So I'm going to have 8.716 plus or minus, then my t that we already figured out, t sub 0.05 with a degree of freedom of 10. Click up to the side. We need to find what the S number is. The S number there is, if I'm looking here, we have to find the S number. All right, next part. We have to find what the S value is. The S value is found by taking the square root of the mean of the square error number. Mean of the square error. So we've got to take the square root of 12.80 in order to find S to go in our formula. So if you go ahead and grab your calculator and do the square root of 12.80, I get 3.57777. We're going to carry our intermediate calculations out probably to at least 3 or 4 decimal places. And so I carried it out to the 3.5777. Usually I like to carry it out at least, oh, does it tell me? It does. Carry your intermediate computations to 4 decimal places. So we want to go at least that far. This number here then is going to go in for my S number, 3.5777. On the end of my equation, I'm going to do the square root of 1 plus whatever this number is that they got by doing this big, long, crazy calculation. In this case, 0.0846. Now these ones you've got to do on your LX calculator because you have to do the T sub. So make sure when you punch that in, 8.716 plus or minus T sub 0.05 degrees of freedom of 10. Click up so you're out of the lowercase subscript, and then put times my 3.5777 and then times the square root of 1 plus 0.0846. I'm going to give you a little bit here to get that punched into your LX calculator. And when I did that, I have 1.963 so forth was my lower end, to 15.469 and so forth is my upper end. Again, due to rounding, you may have slightly different answers, but they should be pretty close. We are going to round our answer to only 1 decimal place. So if I'm going to round this to 1 decimal place, I have a 6 behind my 9, which means I have to round that up to a 10. So 1.96 is going to round off to 2.0, right? 1 decimal place, my 9 rounded up to a 10, so I had to carry. And then the other one's easier to round. 15.46, I'm going to round off to 15.5. All right, so that one part of that question, really long because I've got to do a number of calculations in order to find just those 2 values. The next part of the question, it says, Choose one response to answer the question below. Consider, but do not actually compute, the 90% confidence interval for the mean rental revenue when the theater revenue is $32.6. How would this confidence interval compare to the prediction interval? So they're asking about how would the confidence interval compare to the prediction interval. What we found here is the prediction interval. On the next problem, we'll do a confidence interval. So, how would they compare, assuming that both intervals are computed from the same sample data? So, when I'm doing this, the confidence interval is usually narrower. The prediction interval is usually the opposite, wider. So I want to think about this one's more narrow, this one's wider, gives you more options. Confidence interval narrower. And in this case then, I'm going to have the same center. So on these ones, when I'm comparing these two things, we know we always have the same center. So in your drop down, one of your choices and the answer to this question, because I'm doing the confidence interval first, the confidence interval is narrower, but, oops, they switched that around to me. The confidence interval, I should start with, has the same center, but is narrower. So when I'm comparing the confidence interval to the prediction interval, the confidence interval is narrower, but we're going to have the same center. So they put the same center first and then the narrower second. Just kind of watch how they word that. If it were switched around and they had the prediction interval first, or ask about the prediction interval, you'd still have the same center, but then it'd be the wider instead of the narrower. Second, or the last part of that question, choose one response again. So it says, for the theater revenue values in this sample, $62.6 million is more extreme than $32.6 million. That is, 62.6 is farther from the sample mean than 32.6. How would a 90% prediction interval for the mean rental revenue when the theater revenue is $62.6 million compared to the 90% prediction interval for the mean rental revenue when the theater revenue is $32.6 million? So, in this case, since I'm comparing two different numbers, you're going to have different centers. Okay? Different centers. So, when you're clicking your answer on your drop down, whichever number is bigger or wider, farther away, notice it says more extreme, you got to pay attention to which one it has. But in this case, it's going to compare the 62.6. The 62.6 was more extreme, so it's wider. And then it's going to have different centers because I compared two different numbers. So it's going to be wider because it's more extreme, and it's going to have different centers because I'm comparing 62.6 to 32.6, and I'm comparing two different values. Whereas up here I was comparing with the same 32.6, that's why they had the same center. All right. Number 5 then. All right, on number 5 here, it says an electric utility is examining the relationship between temperature and electricity use in its service region on warm days. The utility has bivariate data detailing the maximum temperature denoted by X in degrees Fahrenheit, and the electricity used denoted by Y in thousands of kilowatt hours for a sample of 30 warm days. For these data, the utility has computed the least squares regression equation to be y hat equals 55.51 plus 3.04x. Tomorrow's forecast high temperature is 87 degrees Fahrenheit. With this in mind, utility managers have used the regression equation to predict tomorrow's electricity use. But they're also interested in both a prediction interval for the electricity use and a confidence interval for the mean electricity use on days for which the maximum temperature is 87 degrees Fahrenheit. The managers have computed the following data. So again, they're giving you the mean of square error, and then they're giving you this value that we used in the formula. Based on this information and assuming the regression assumption holds, answers the question in the table below. So on this one, we want to know what is the 90% confidence interval. If you remember on number 4, they asked you for the prediction interval instead of the confidence interval. So the formula is just a little bit different than what we did on number 4. So this time, when we do the confidence interval, see if I can squeeze the formula in there. Again, we start with y hat, then we have our plus or minus, and our T alpha divided by 2 with our degree of freedom, which is n minus 2, just like we did before. We're going to take that times S.
Anyone owning a blue truck, a blue Dodge truck with 3 county license plates? Your lights are on in the parking lot. Anyone owning an older blue Dodge truck with 3 county license plates? Your lights are on. Thank you.
We take it times S, which we're going to calculate, and we calculated S on the previous one. And then and this is the part that's different on our formula. Here you're just going to have the square root of that given number. On the prediction interval, you have 1 plus the number. So you have to pay attention. Are you doing the confidence interval or are you doing the prediction interval? For the confidence interval, we just use this given number. If we're doing the prediction interval, we add 1 to that number. So that's the difference in the two formulas. So in this one, if we're going to predict this, first of all, we are going to calculate our y hat value for 87 degrees. So we're going to put 87 in there and do our calculation. So we are going to have 55.51 plus 3.04 times 87. And we are going to multiply that out. Got to grab my calculator. And so 55.51 plus 3.04 times our 87 gives us 319.99. That's going to go in for our y hat value, 319.99. Plus or minus, I'm going to put the T down here. Now remember, this here comes from your confidence interval. If I have a 90% confidence interval, that this is 90%, so 100 minus 90 gives me 10%. I have 2 sections on my thing, so I'm going to divide it by 2. So each of these are 5%, and so I'm going to use 0.05 for my subscript. I'm going to go down here even though that continues on. T sub 0.05. My degree of freedom is n minus 2, so I have to figure out here on my data, we did a random sample for 30 warm days, so 30 is my n value. And so I'm going to do 30 minus 2. 30 minus 2 would give me 28 there, right? N minus 2, 30 minus 2 is 28. So you could put 30 minus 2, but I'm just going to put the 28. Now I have to do my S value that I have to multiply by. Remember that the formula for S was that we were taking the square root of the MSE, the mean square error. So we're going to do the square root of 762.57. Square root of 762.57 is 27.614. I'm going to round it off to 7 because we want to do our intermediate calculations to at least 4 decimal places. So this again is going to go behind here, 27.6147, and then again I'm running out of room under my square root, which goes behind there. My square root here again, I don't have the 1 plus that number, I just have that number. So I'm going to do 0.0368. So on your Alex calculator, again, all this should go in one line. I just don't have room to write it here. 319.99, the plus or minus, T sub 0.05 with a degree of freedom of 28. Click up behind there, times my 27.6147, times my square root of 0.0368. Now again, depending on rounding, you may get a slightly different number, but should be pretty close. When I round off to the 1 decimal place, you should be getting 311.0, or at least something very close to that, and 329.0. Again, it does give you some leeway on Alex because of rounding. You could, instead of using this rounded off number, just type in the square root of 72.57 here. And then you may not get your rounding errors. So either way, it should give you at least close to the same answer. And Alex understands that because we're rounding, we might get slightly different answers. All right, so that's that big long calculation for number 1. Now the rest of the part is kind of just answering our questions below. It says, consider but do not actually compute the 90% prediction interval for the individual value for electricity when the maximum temperature is 87. How would the prediction interval compare to the confidence interval? Remember that the prediction interval is always wider and the confidence interval is always narrow. So prediction interval will be wider. So again, you're going to choose that which one you're going to have. When you're comparing with the same temperature, you should have the same center. So it's going to say the prediction interval will have the same center, but be wider. Something to that effect the drop down will say. Prediction interval is always wider. Confidence interval will be narrower. Since I'm using the same temperature, I'm going to have the same center. Part 3. For the maximum temperature values in this sample, 95 degrees Fahrenheit is more extreme than 87 degrees Fahrenheit. That is, 95 is farther from the sample mean. How would the 90% confidence interval for the mean electricity when the maximum temperature is 95 degrees compare to the 90% confidence interval for the maximum electricity when the maximum temperature is 87? So now I'm comparing 2 different temperatures. I'm going to have different centers, right? So I know I'm going to have a different center. Now you have to pay attention to which one they're asking, they're starting with. Here, they're doing the bigger number. The bigger number is going to give you a wider sample. The smaller number that's closer, right? It told you that the 95 was more extreme. So we're going to have 95 is wider. It's more extreme, but it's going to have a different center. And sometimes they switch those around and they'll say it's a different center and is wider, but those 2 words will be in there somewhere. If they would have started off with the 87 would have been narrower, but you still would have had a different center. All right, we got one more of those long ones to do here. The well-known psychologist Dr. Elbod, whatever his name is, I don't know him, so he's really not well known, has established what he calls his generalized anxiety GA scale. The GA scale, which is a scale from 0 to 10, measures the general anxiety of an individual, with higher GA scores corresponding to more anxiety. Dr. Elbod's assessment of anxiety is based on a variety of measures, both physiological and psychological. There we go. We'd like to make predictions about individual sleep behavior based on their GA scores. We've collected bivariate data that gives the GA score denoted by X and the number of hours of sleep last night denoted by Y for each of the 10 adults participating in the study. There's my N value. N is going to equal 10. The least square regression equation, y hat equals 8.91 minus 3.2x. We have used this equation to predict tonight's sleep time for a woman whose GA score is 6. We're now interested in both a prediction interval for her sleep time and a confidence interval for the mean sleep time of the individuals with her GA score. We have computed the following data. Again, we have the mean square error. We use that to calculate S because we know S is equal to the square root of that mean square error. They also give you this value here, which is going to be part of your formula that I like to put little asterisks on. So, based on this information, what is the 90% confidence interval? So again, on number 6, we're doing the confidence interval instead of the prediction interval, so we don't have to add the 1 under our square root. So confidence interval, we're going to do the y hat plus or minus the t sub alpha divided by 2 with our degree of freedom of n minus 1 times our S value times the square root of whatever that number is that they've already calculated for us. Confidence interval, you use just the number. Prediction interval, we have to add 1 to that number. So watch to see what they're asking for. Again, we have a 90% confidence interval. I'm hoping you remember if it's 90%, we're going to have 10% left over divided by 2. So our t subscript will be 0.05. If I'm going with my degrees of freedom is n minus 2, so 10 minus 2 is going to give me 8 degrees of freedom. I have to start by calculating y hat. Y hat is equal to 8.91 minus 0.32 times our x value. We are using an x value of 6 since we're predicting what that is. It also tells you right here what's the GA score if my x value is 6. So I want to put 6.0 in there, and then again I have to grab my calculator in order to do my calculation. So 8.91 minus 0.32 times 6 gives us 6.99. So now I'm going to substitute that into my formula. 6.99 plus or minus t sub 0.05 with a degree of freedom of 8 times my S value. Again, just to eliminate some of the rounding errors, I maybe wouldn't just calculate that out and round it off even though it tells you can. You could just put it in this way, square root of 0.570. If you want to calculate it and then use 4 digits at least, that's okay too. And then we want to multiply that by the square root of this number right here, 0.1145. Again, all that should go in one line with this stuff raised up out of that subscript from your t. So 6.99 plus or minus t sub 0.05 with the degree of freedom of 8. Click up to the side times the square root of 0.570 times the square root of 0.1145. So rounding your answers off to, this one says 2 decimal places. You should be close to 6.52 for your lower limit and 7.47 for your upper limit. Again, it may be slightly different depending on rounding. So if you got something that's very close to that, it's still going to be okay. It's going to count it correct. Part 2, we are going to do the prediction interval. It says consider but do not actually compute the 90% prediction interval for the individual values for sleep time when the GA score is 6. How would the confidence interval compare to the prediction interval? So on here again, I'm comparing at the same GA score. I know somewhere in there it's going to say it has the same center. On the drop down, you have to watch, does it ask for the prediction interval first or the confidence interval? On this one, it happened to say the prediction interval. So the prediction interval has the same center, and we know the prediction interval is always going to give us a wider answer. The narrower one is the confidence interval. So if it says the prediction interval, you're going to use the word wider. If it says confidence interval, we would have used narrower. Part 3, for the GA score in this sample, if I use 8.1, 8.1 is more extreme than the 6.0 because it's farther from the mean. How would the 90% confidence interval for the mean sleep time when the GA score is 6.0 compare to the 90% confidence interval for the mean sleep time when the GA score is 8.1? So again, pay attention here. On this one, the drop down asked for the 6.0, not the 8.1. We're used to it asking for that first one. It asks for this one. This one is closer because the 8.1 was more extreme, so that smaller number is going to be narrower. But of course, since we're comparing 2 different values, we're going to have different centers. So just watch that, because here they may use confidence interval instead of prediction interval. Here they may use either one of these 2 numbers. The 8.1 was more extreme, so it would be wider than the 6.0, which would be narrower. So watch for that, because they will switch those around on you.